Come on, little buddy. Come on, little YouTube. You can do it. Okay. In theory, we are live. Why is
Hello, humans.
somebody needs to confirm our very existence.
Okay, let me find the Twitch stream.
Yes.
Yes, we're live.
Yeah, people are saying we're live.
No, this is how you get banished.
Okay, great.
No.
Yeah, Corey S. Notice I got the new camera going. So,
Is this one of the Sony mirrorless ones?
yeah, this is the Sony A7C, and it had a bad like synchronization rate, and so I have a USB capture card for my computer, and I was able to get an HDMI out, but the Sony camera requires a funny sized micro HDMI, not a mini HDMI, a micro HDMI. It's a special, I don't know if it's a Sony thing or whatever. So
yeah, it's a Sony thing. I have a Sony camera that requires one.
Yeah, so I had to go to that, and so I was just fussing with that, and so I had the whole system kind of broken and messed up. Yeah, and so finally, just at the last minute, and so I still haven't got it. So it's bringing it in at 60 frames a second, but it's not displaying it at 60 frames a second. So I have to figure out how to make OBS properly output at 60 frames a second. And so in theory, then I can actually do a live stream at 60 frames a second, which is a lot better.
Yeah.
But
that's deeply confusing. That should be an easy thing
there's like
to deal with.
All of the settings are locked off, and apparently there's a way to. You have to unclick something that allows advanced control of the camera to make sure that this recording is different from the streaming. But anyway,
can you make it simpler by simply going through a video converter?
Well, that's what it is.
HDMI to USB-C.
That's what I'm doing. Yeah,
and it's still giving you the okay.
Yeah, it's an OBS thing. There's a setting in OBS. Yeah.
Why I use Wirecast.
Yes. Yes. I will find the button. I will find the right. I will figure out the right series of buttons to press at the right time to be able to make it go. But it's cool. It's funny. So I had this other camera that I really loved. I was using the Panasonic Lumix GH5, but it had an unreliable autofocus.
Oh.
And so it's
that's no bueno.
No, it's the worst. And so you record your video. And then you take a look at it after the fact, and you can see the camera seeking autofocus. And you're like, well, I can't trust this thing ever. And while now you can't see this, but the audience can. Which is that it just tracks your eyes. You on the little preview, I can just see little boxes on my eyes at all times. So it knows where my eyes are. And that's it. Just nail that one thing, make the camera reliable, and then we can trust it.
Yes.
So I had to change my entire camera system. So my dad is now using my Lumix, which is great because he's a giant Lumix fan. And what he really wants is to like it. Is that a whining dog? Oh, okay.
No, it was a squeaky toy.
Another squeaky toy goes.
So this chair, because there's a I don't know why, but the wall is one brick deeper here than here.
Yeah.
So the chair is one brick away from the wall, and once a week I pull it back and pull all the dog toys that have been banished behind it because I'm streaming and she won't stop. And she's eventually going to figure out that if I'm talking at the screen, oh, good Lord. Another one. I've been brought another one.
That's so funny.
They go behind the chair.
Okay. All right. Someone thought it was the moving the mic was making the whale song, but it's actually the squeaky toy.
Yeah, it was totally the squeaky toy.
So we need someone in the audience to keep an eye on SN11.
Yes, we will switch if it looks like that sucker is going to go.
Yeah, we'll drop everything.
Yeah, because I want to see it either go boom or not go boom.
Yeah.
I loved the accidental second hop last time.
Yeah, it flew twice. Yeah. So someone keep an eye on it. If SN11, I mean, it looks like it's probably not going to happen in the next probably hour plus.
Yeah,
but
we should be okay.
The timing could be tight. So someone let us know as they get to the right phase, and hopefully it doesn't hit us within the within that brief window.
Yeah.
So, okay, we got a couple of people mentioning that they're watching, so keep us posted. All right, are you ready?
Yeah, I think I have gotten everything away from the dog that she can squeak at me.
Wait a minute. What? Oh, okay, I'm all right. A binary thing, boom or no boom. Okay, well, let's call it. Let's call it right now.
I think this time there will be no boom, but it will not be perfect. Stella agrees.
Boom.
Okay, I have to get rid of this dog. I'm so sorry, everyone. One moment.
Here's why I think boom. I think. I mean, it's all in the landing. It's all is, can they make the spacecraft touch down softly enough for the legs to be able to absorb the impact of the landing? And I think that there is a fundamental, like, they've got it into the right position, but it came down too hard. And I think it's going to keep coming down too hard. Like it's got to come down, like with the Falcon 9, they've got these gigantic legs. They're really big, and they absorb a ton of impact because the mass of the rocket, compared to the mass of the legs is different. But with Starship, they've really focused on making the legs almost non-existent. They are collapsible, I think, titanium little nubbins that flip out from underneath the bottom of the rocket. And that means because you don't have a lot of tolerance in the legs, they've got to nail the landing within just almost no tolerance. And I think that's the problem. And so were I them, I would way overbuild the legs. I would build just crazy huge legs. And people would be like, is it going to have legs that big? You're like, no, it's not going to have legs that big. But we need to measure the weight that's being transferred to those legs on every landing. And we've got to keep practicing these landings until we get these landings within this tolerance level. And then we can downscale the legs to a proper final length. But it's
I do appreciate that they started lighting all three engines to make sure they have two.
Yeah. But I just think, like, with those tiny little legs, they just don't have any, and it's not like, I'd have big old springy legs. Like put as much as weight, because the thing's flying mostly empty mass, so it can handle more weight as it's doing its flight.
Yeah.
And I think that's the key, is they've got to maintain the safety of the vehicle while they're testing these things out. And if they're just going to keep using that final setup, I think they're not learning enough. They could have been flying this thing many more times. So I think that my guess is it'll go boom again, and it'll be the legs again, and they will come up with a better solution for this. Musk was already leaning towards no legs, so some way to catch it instead. And that seems to make sense, right? That you have all the leg infrastructure built into the catcher. And you can have the thing just like, fire and then just
But
land
that
in a net and
work
then just
on Mars or the moon.
One problem at a time.
I know.
And the gravity on the moon and the gravity on Mars is way lower, so you don't have to handle that same kind of crunch.
So one of the things that I'm looking forward to is they're planning to only test 2 of the giant boosters before going to orbit.
Right.
And so the question is that realistic with these giant scale-ups of the Falcon 9 boosters?
Yeah. And it's the same, I mean, probably everything is going to work. Like, it doesn't have to do that crazy flip maneuver. Right. You've got to make whatever 39 engines work in concert. That's interesting. But
that's just computational power. Thread the processes.
Sure. Yeah. But the key is going to be for it to be able to have a way to catch it softly. Yeah. And so if they're going to use a crane to catch the one thing, they should use a crane to catch the other thing. And you know, like, they can get creative. Like, what about and I'm sure they've thought about everything, right? But just imagine, what if there was like some kind of hook on the top of the Starship, and so the thing, because Starship can be positive. It doesn't have to, like, Falcon 9 has to hover slam. Starship can hover. And so you could imagine it sort of getting down to a point and then just getting caught at the top, and it's done. So, yeah, I think the legs are the problem now. There you go. Big foam pit. Someone's, bouncy balls. That sounds good. Water. Just landed in water. Yeah.
So which do you think is going to happen first? Orbital Starship or orbital SLS?
Oh, orbital Starship. Yeah.
There's so much propaganda coming out of NASA about SLS, reminding people that their green test went okay.
Yeah, with the rocket fire for 8 whole minutes. We're halfway to the moon.
And just I'm dumbfounded that they have one and only one version of their disposable rocket.
Yeah. It's not like there's multiple SLSs. It's SLS.
Right. And yeah.
And it won't have the launch capacity of Starship. Like, every day that this goes on. Yeah. Yeah. It's seeing people complain about, say, the space shuttle. I sort of watched this argument that was happening on Twitter, and people, someone was like, man, the Starship is like the worst thing ever made. And I'm just like, are you crazy? Like, the space shuttle is probably the finest machine that humanity has ever created. It just never should have been built.
Old beater of a pickup truck?
Yeah, it was pretty awesome. It just should have never been built. Yeah, that's all. It is beautiful in every single part of it.
We failed to understand how complex those tiles were going to be.
Yeah, every part of it. Every part of it is magnificent. The RS-25 engines, the fact that it does a landing on a runway, the solid rocket boosters, the main fuel tank, the foam, the fuel, the heat tiles, all of the avionics, the Canadarm, of course. Every part of it is just the greatest challenge to an engineering problem the greatest solution to an engineering problem that should never have been asked. Just like this horrible mass, like this sort of octopus's tentacles of compromised goals, and solve it.
I have to say, the idea of having a takes off like a rocket, lands like an airplane is a noble idea.
Mm-hmm. And they had solved this problem. They had theoretically solved it back in the 1960s with a 2-stage, both halves landed like airplanes. It was so cool.
Yeah.
All right. Yeah. What do we do? Why are we here?
I think we're supposed to record a podcast.
Okay. All right.
Maybe.
All right.
Do you have Allie in Slack? She's gonna give you the hey, you've been talking a while notices.
Well, she has to do it in YouTube because I can't change to Slack because I'm displaying Slack.
That makes sense.
Yeah.
So where should she do it in YouTube?
In YouTube, just on the YouTube chat.
Okay, that works.
Yeah.
Okay.
Yeah.
I hope you heard that, Allie.
I'll try to remember.
It will be. I think her username's in English.
Okay.
I will
I'll upscale moderate her if she posts in the YouTube chat.
Okay.
And that way we can keep an eye on her.
Okay, so Allie, just say, I am Allie.
Okay. Wait, don't. Now you're going to have 5 people saying I am Allie, and then I won't know. Who's
it should be Allie? In English.
All right.
Either that or she'll use her actual name. So.
Okay.
Oh, man. I forgot to eat lunch before we record.
Yeah, me too. I'm starving.
All right. So the mics may catch grumbling tummies.
All right. Let me know when you're ready.
I am finding I buried our audio window. This is episode 600. I'm pressing record.
I've also pressed record.
So have I. I am recording.
Okay, here we go. Astronomy Cast, episode 600. Looking into the future. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. We are really earning our wings today as the oldest continuously running astronomy podcast, and it's awesome.
Is that how that works? Is that how you get your astronaut wings?
I didn't say astronaut wings. I just said wings.
Just regular wings. No, I want my astronaut wings. You hit 600 episodes, you get your astronaut wings, or fly to space, one or the other. And we accomplished one. Yeah, that's pretty amazing. All right, so today we are going to gaze into the future of space and astronomy. What upcoming missions, events are we excited about? And we will talk about that in a second. But first, let's have a break. All right, Pamela, 600 episodes. Crazy. But we don't look back.
No, because science evolves. And what's crazy is I know some of the things I'm going to look forward to today are things I didn't even think were possible when we started recording and would have blatantly told you are not possible.
I 100% agree. And I think one of the things that I always find is, like, when you talk about some of these really far-flung missions, people are always they go like, 2035, 2045 for a mission. I'll be 60 by then or whatever. I'll be in my 70s or something. But don't worry. There's so many really cool things happening all the time, every year, year after year after year, that you don't have to worry about what the far future holds, because there will be enough stuff happening in the short term to keep you wildly entertained throughout this entire thing. So we will definitely talk about stuff that's going to happen in the far future, but we will also talk about a bunch of stuff that's happening in the near future. How do you want to organize this? Where do you want to go?
So why don't we look to the missions that we are most excited about, the kinds of discoveries that we hope will be made, and then the crazy ideas that we're hoping someone will prove or disprove before it's all over.
That sounds great. So let's start with observatories and sort of like astronomy-related observatories and missions that connect to, astrophysics and astronomy first, as opposed to exploration.
Okay. So I think the Extremely Large Telescope is where it's at. These tens of meter systems that are coming up, they're going to hopefully change everything. But before they get here, we're going to have the Veer Rubin Large Synoptic Survey Telescope down in Chile, hopefully by the end of this year. So I don't feel like we're working too far ahead looking at that one.
And yeah, I mean, to have a telescope that we have been, incredibly enthusiastically excited about what feels like a decade.
More than a decade. I started talking about that scope back in 2008.
Did you? Okay, yeah. But, it has reached the point now where it's going to be doing first light later this year. So
yeah.
How will Veer Rubin change our understanding of the cosmos?
Well, the thing I personally am looking most forward to is that sucker as it observes the entire sky in just a few nights, the entire visible sky in just a few nights. It's going to be able to see the entirety of the ecliptic over the course of the year in never before seen detail. And if it doesn't find planet 9 within the first 2 years,
it doesn't exist.
Probably not out there.
Yeah.
So I want to know what other Kuiper Belt objects, what other planets are in our own solar system. And it will finally tell us. Beyond that, it's finally going to allow us to survey just what is the distribution of all those little asteroids that are threatening to crash into our planet. What is the distribution of all the Trojan objects out orbiting with Jupiter and beyond? And beyond also includes what's the distribution of the faintest stars and the transient objects, the things that go flicker and flare in the night, beyond our solar system and beyond our galaxy.
I always like to describe this as like right now, all we ever get to look at is a photograph of the night sky. And Veer Rubin will give us a video.
Yes.
And we will see what the universe is doing night after night as it changes, as it evolves, as things happen. We can see how vibrant and just how ever-changing the universe itself is. And
it's going to let us see all the rare stuff. Mm-hmm. Just because it sees so much.
So Veer Rubin is a big telescope, 8+ meter telescope. But I think right around the corner from that are a whole nother class of even bigger telescopes.
And this is where we have the extremely large telescope, which I have faith will actually be finished. The 30-meter telescope, which seems to be stuck in purgatory of unknown construction. There's many of these under discussion, but I think it's going to be the extremely large telescope that reaches completion first down in the southern hemisphere. And with its tens of meter mirror is going to have the light gathering power to allow us to start to do spectroscopy, separating out the individual atoms of the faintest and most distant objects in the sky.
Yeah, just for comparison, the current biggest telescopes in the world, you could say it's the Very Large Telescope, which is 4 8-meter telescopes that work like one big telescope. The Extremely Large Telescope is going to be just shy of 40 meters, a single telescope with a 40-meter mirror, 39 meters. It'll be able to see exoplanets directly. It's going to be able to peer out deeper into the universe. It will outclass every astronomy tool that exists on Earth and many in space. It's crazy. And that's like 2026.
I suspect that engineering difficulties and COVID will delay it a bit, but not as much as JWST has been delayed.
Right. So those are the, I think, and then there's a bunch of other observatories,
Square
as you
kilometer
said.
array.
Okay, so let's talk about that.
So this is another mega system where we're looking at dozens of telescopes scattered across southern Africa and the outback of Australia, tuned to different long wavelengths of light. And they're going to be able to see things that we don't have the technology to see right now. We're getting glimpses with Meerkat and some of the other devices, but through a combination of looking in these longer wavelengths that we're just now starting to see on a regular basis, and by having a resolution by spreading these telescopes out so far, it will see smaller things, fainter things, and in a just starting to be studied color of light. and we don't know what we're going to find. And that's what's so awesome.
Yeah, yeah. I mean, I know I mention this all the time, that it will be capable of detecting the leaked radio emissions from the Earth's airports at about 100 light years away. So it would detect airport chatter. But I mean, it's going to be looking out deep into the universe, seeing some of the first events. It's going to be detecting emissions from stars. It's crazy what it's going to be able to do. And it joins these super telescopes. Veer, Rubin for seeing fast changing stuff, extremely large telescope for just like massive light,
high resolution.
Light gathering power, and then the square kilometer array for just total area, 1 kilometer size telescope. Just madness. What about space?
Someday, maybe we will know if the JWST
October 31st, 2021. That's the date. It's not changing. It's changing.
I will believe it when I see it. I feel like we almost need one of those surveys like you do, when's the woman going to give birth to the child, where everyone gets where whoever gets closest without going over gets the prize. And if we do that, someone's going to say 2025 or something. So JWST, hopefully later this year. The one I'm really looking forward to is Bepi Colombo finally making it to Mercury with all the new instruments it's carrying, and letting us go back and see more of the things that Messenger gave us hints of. The idea of past explosive volcanism on Mercury, of there being ice in some of the shadowed regions, helping us understand what's the history of this world that has shrank over time and been tortured by the sun. I want to see what Bepi Colombo will see.
All right, well, we're going to talk about some more in a second, but first let's have another break. And we're back. Now, you talk about Bepi Colombo, Mercury. You've already skipped into planetary science stuff. I'm super excited. No, it's fine. It's fine. Challenge accepted. No, what I'm really excited about is this next set of planet hunting missions that are coming. Right now we've got TESS, which has really demonstrated that we can find planets nearby the Earth. And now there are plans, both from the European Space Agency and from NASA, to launch a series of missions to take all of this to the next level. You've got Ariel, which is 2028, which is going to be observing atmospheres of other planets. Like, its job is to observe atmospheres of planets. You've got the potential for the HABEX mission coming in maybe 2030, 2035, which will sort of take that to the next level, observing Earth-sized worlds and their atmospheres. There's Plato. There's a new mission on the books from NASA called Pandora. They're thinking of sort of a similar thing. So you've got just a whole string. Probably every 2 years or so, there's going to be a new planet hunting, either Earth-based or space-based mission that's going to figure out some aspect of the planets.
And the thing that gets me is there's also these generalized missions that it sometimes feels like we're no longer launching. WFIRST, which has been named the Nancy Grace Roman Telescope, it's one that was originally said to be the dark energy mission. But then it was realized, wait, we can use this for planet hunting. We can use this for so many other things. So we are going to continue to have these Hubble-like missions that can bridge across all the different sciences. And with Hubble starting to reach middle age and somehow still functioning, it's nice to know there's another optical telescope up and ready to be launched in the coming years.
All right, so let's shift some gears, and there's too many to even name, but let's shift some gears and talk about some other planetary missions that we're excited about. First, of course, is Europa Clipper, which is in development, and that's going to be sending a mission to Europa to search for water under the surface of the ice on Europa, try to really understand what's going on there, and try and give us some kind of clue if there's going to be life. That's going to be one of those ones you're going to need to be patient for because it's still under construction. It's a long flight all the way out to Jupiter and Europa, but stay tuned.
And there's the Trident mission potentially going to Triton. It hasn't been fully funded yet. It's in the works. There's Dragonfly, which is funded to go to Titan and flit about in its atmosphere. Maybe figure out for once and all if the planet really is chemically out of balance and the potential for having life. We're also looking at so many different things being developed to go to Venus with this constant parade of papers in the literature saying, wait, there could be life. Wait, there's not life. We don't know. We need more data, and hopefully there will be a Venus mission selected that will dip down into the atmosphere and allow us to know what really is and is not there in that hot world's upper boundaries.
Yeah, Venus is now at this point kind of criminally underexplored. And so it really makes sense for us to go back to Venus. Now, there have been some missions that have been launched. They're in the process of helping us understand, moving into position to help us study the sun. And I'm really excited about as these do it. Parker Solar Probe, which we've talked about, it's still just getting closer and closer with each orbit until the point that it's going to be just a few million kilometers away from the sun, capturing the closest images we've ever seen. You got the European Space Agency Solar Orbiter, which is moving into its position to start showing us the sun from other latitudes, showing us above and below the sun. And then you match that with the Daniel K. Inouye telescope, which has
that's amazing.
Just really come online. And I think there's still like one more instrument that isn't fully going yet. And so you take those three observatories together. And I think there's one more as well. They are the James Webb Extremely Large Telescope of the sun, and they're all moving into position. And so our understanding of the sun, of how the solar wind gets produced, how solar storms are generated, and as they reach the Earth, that's all going to get figured out in the next decade. So we're going to watch all this happen, just discovery by discovery.
It's really amazing. And this is where you have to start wondering, what are we on the crux of discovering? And it makes me think back, I know we're not going to go back in history, but it makes me think back to 50 years ago when we were just starting to get back data on, it's now closer to 60 years ago, we were just starting to get back temperature data on Venus, starting to get images back of Mars. And suddenly we realized, oh, expletive, those aren't super habitable worlds like we had thought. But as we're now starting to understand that there's water everywhere, are we going to realize that there's microbes everywhere as well? Is there bigger life in the oceans of Pluto, of Enceladus, of Europa? There's more habitable volume, if you believe Alan Stern's work, in Pluto than there is on Earth.
Yeah. All right. Well, we're going to talk about some mission concepts that we're excited about, things that we hope, and we'll talk about that in a second. But first, let's have a break. And we're back. So now we've talked about all the missions that we know are going to happen, and of course we're missing dozens, I'm sure.
Yes.
And so I'd love to talk about what we're excited about, and one thing, just before we even kind of go into this conversation, for me, the thing that I'm really excited about is how many other nations are getting involved in space and astronomy and space exploration. So up until this point, it's always been NASA and ESA. And
Roscosmos, don't forget Roscosmos.
Sure, for sure. Less so on the science side, although they recently launched a really cool X-ray satellite. But you've got, for example, the Chinese are doing a lot of great work with radio telescopes, both on Earth and out in space. They've got a mission at the far side of the moon. They've got a rover going to Mars that's going to be joining Perseverance and Curiosity on the surface of Mars. It's going to be landing soon. They've been bringing samples back from the moon, and they've detailed there's going to be a mission to an asteroid. They're going to be doing a sample return mission from an asteroid. Experiments to do in situ resource utilization. You've got the United Arab Emirates with their mission to Mars. You've got all the hard work that India is doing with the moon.
And Japan's robots that it flings at things.
Yeah.
I'm still giggling at Hayabusa 2, just dropping stuff on Ryugu. It was amazing. Yeah, they have more planned.
They've got a mission going to Deimos and Phobos potentially. India has also sent a mission to Mars. The various groups are working on space stations, and so I think one of the big themes that we're really going to see in the next couple of decades is just how much the rest of the world gets involved in space exploration and makes some serious contributions to space and astronomy. It's competition's always a good thing. I love it.
And what's getting me is it's not just the spacecraft, it's also the particle detectors, where we see nations like Italy and Spain all getting in there and being like, okay, we're going to figure this out too. And as we're trying to figure out gravitational waves, you see India building its own detectors as well. And hopefully we're entering a new era where we're looking at what's called multi-messenger astronomy. This is where we're combining data from gravitational waves, from particle detectors, from telescopes that detect light in all its various colors. And by pulling all this varied information together, for the first time, I actually think it might be possible that we'll start to get data from before the formation of the cosmic microwave background. I would never have said that in the past.
Yes. In fact, you grumble.
Adamantly said we will never. I was wrong.
Yeah. Grumble. Gravitational waves. Grumble. If I
recall. Grumbled LIGO, and I stand by my grumble of early LIGO.
All right. Okay.
It's better now.
It's better now. It's advanced now. Has more detectors. But yeah, I mean, even in other. There's other kinds of ways of looking at the universe that people are starting to figure out. And so there is, say, we have the ice cube detector down in Antarctica. They're planning a upgrade that will turn it from 1 cubic kilometer of ice to 10 cubic kilometers of ice to try and search for neutrinos and even potentially even a neutrino background to the universe. There's massive new gravitational wave observatories in the works. LIGO, I think, has 10-kilometer long arms. There's one that's being planned that'll have 40-kilometer long arms.
And Lisa maybe will finally be given a chance to fly.
Yeah, a space-based version of LIGO, Lisa, and which will be terrific. So we've got the potential to see the universe in neutrinos, to see the universe in gravitational waves, and a lot of these big problems, these big mysteries that we struggle with today will just get solved.
And Large Hadron Collider is going to be coming out at higher energies. And it's finally going to, I think, put a nail in the coffin of supersymmetry and start saying these dark matter possibilities are or are not real. And it takes so many different kinds of detectors to figure out all the different scales of things we need to understand our universe. And the world is investing in it, not as much as any of us would like, but the world, not always the country you would like.
Right.
The world is investing in science with the Large Hadron Collider, with all the gravitational wave detectors, with these multi-tens of meter telescopes, square kilometer arrays. The world is figuring out our universe as we work together.
So one last question. What is a mission that you wish somebody would figure out? That no one is, or a scientific question that you wish somebody would go to actually solve?
I really wish we could figure out a better way to convince neutrinos that they need to interact with us. I think there's a lot about neutrinos that we still need to figure out. And I wonder if they are the bridge to understanding dark matter that we need. I want to know more about neutrinos. It's just that simple.
Yeah.
What about you?
For me, it's searching for biosignatures. I think I would love to see a space-based interferometer that has the capability of observing extrasolar planets, multiple pixels of extrasolar planets, try to piece together, can we see the continents, the oceans? Can we start to measure brightness, clouds, that kind of thing? Maybe even city lights at night. So I think if you can
that's in the way, though. I think that will come.
Yeah, I think multiple kilometer size space-based interferometers would be lovely. So I think we are hopefully going to, the point being, every few months there's going to be something exciting that's going to happen in space and astronomy. Both have been doing this now for decades. We can confirm that it has happened throughout our entire careers, and so there's so much.
And we'll be wrong stuff. Again.
Yeah. And of course even the most exciting thing is the that's strange discovery, like dark energy or fast radio bursts. So there's lots more the universe has in store for us. Thank you, Pamela.
Thank you, Fraser. Happy 600.
We did it. All right. Do you have some names for us this week?
I do. So as always, we are here thanks to the generous contributions of people like you. It takes a whole crew to keep Fraser and I on the straight and narrow. There's Nancy running Herd, Allie doing video, Rich doing audio. Beth is out there updating websites. So many people involved. And because of you, we can keep them employed. So this week, I want to thank Burry Gowen, Birko Roland, Kevin Lyle, Andrew Poelstra, Brian Cagle, David Truog, Robert Wenger, Venkatesh Chary, TheGiantNothing. I love that username.
You really do.
Jeanette Wink, Aurora Lipper, Joe Hook David, Gerhard Schwarzer, Laura Kettleson, Robert Plasma, Joe Holstein, Paul Jarman, Les Howard, William, Joss Cunningham, Emily Patterson, and Just Joe. Thank you. You make this possible.
Thank you, everybody. And we'll see all of you next week.
And now we save.
What? I forget. Which episode number is it again?
Yeah.
All right. Won't have trouble forgetting today. It's funny. People always ask me if I'm going to do something special for some date, some number like this. Like, are you going to do anything special for episode 600? Like, we did 600 episodes. That's the special thing.
Yeah.
Now we got to organize something else on top of it.
When we hit 1,000, it'll be time to get together in a bar and drink to it again.
Yeah, maybe. It was, but I really loved that the fans organized something that we could be a part of for episode 500.
We have the best fans. Hands down, we have the best fans. It's just that simple.
Can confirm. Okay, I'm going to make sure my episode is uploading. And then, because I will forget. And then Richard will ask me politely, what's going on, Fraser? And I got so much internet now.
That's awesome. So you're really loving the Starlink?
I'm not using the Starlink.
Okay.
Yeah. Do I love the Starlink in general? Yes, Starlink works great. Every day that goes by, it gets better and better and better. It's very fast. Yeah. It's entirely portable. People say that it's probably not that geofenced. So
that has potential.
Yeah, I take it to your Airbnb cabin in the forest. No
your
problem.
Boat.
Take it on the boat. Take it to my dad's house. Yeah, wherever I go, internet.
That is awesome.
Yeah. So no, I mentioned this before, and I really think they're going to run away with this, all of it. Like if anyone thinks that all this is going to be is low quality internet in far-flung places of the globe, no way. They're going to figure out how to make Starlink work with your phone. They're going to figure out they're already figuring out how to put these on cars, boats, trains. So
and during the last FCC auction of bandwidth area, spaces where you could like be responsible, they got a whole bunch of weirdo places, different airport fields and things like that. So they have plans.
Oh, yeah. Yeah, and I think people have been trying to block them because they're not as good as a broadband connection, but
they're not as good as fiber optic.
They're not as good as fiber optic, yeah, but for a lot of like rural internet, they absolutely meet the qualifications of rural broadband requirements.
Yeah, we can't get fiber where I am.
Yeah.
And the second that they can hit, and I think they're close to it, what we're getting from our old school Ethernet cable that runs under the backyard.
Yeah. I would get it as backup anyway.
That's actually a good idea.
But you do need a good line of sight to the sky. Like if you've got any trees.
Oh, we have roof access?
Yes. As long as you have like good view to the sky.
Yeah, we do.
Yeah.
It's scary to get to the roof, but we have good view of the sky.
Gordon is saying if you're not using your Starlink Fraser, I can take it off your hands. Okay, all right, no problem. No way, man. The second they announced the beta test, I put my name on the list, and it's I run it as my backup, but I absolutely will be using it because how many times have I learned that internet is important for my job?
Yeah. You for years had two different sets of internet in your house just to.
Yep. Yeah, I had both major providers of internet going into one modem that then split the internet, and that way, because they were going down like every couple of months, I would be down. It was crazy, and so it's been way better now. Although our biggest telco just bought Rogers just bought Shaw, so it would be like AT&T buying, I don't know, Sprint. Yeah, or something even bigger. It's like we're running out of competition again, which is too bad because what we need is competition. Like, I don't know. Whenever Europeans talk about how much they pay for cell phone service and stuff,
I know.
It's crazy. Like I pay about $80, $85 a month for my cell phone service.
Yeah.
And I can't make a phone call from my house. Right? Like you'd think if I'm going to pay that much money, I would be able to make phone calls, but I can't. No. So I've got to, I got to go outside and I got to get away from the house and I got to move up the hill a little bit to have a good phone call with somebody so that I can, get in better view of the towers. So
thank goodness for voice over IP.
Yes. When it works.
Yeah.
But for whatever reason, the way it's been implemented on my phone, sometimes I can do Wi-Fi calling and sometimes I can't.
Oh, no.
Yeah. It's just like it does. Who knows if it works or doesn't work? Yeah.
Yeah, I have the opposite problem. My phone tries to ring and so does my watch and my headphones and my computer and the iPad.
I should get one of those voice over Wi-Fi, like voice over IP services that's completely separate from my phone system.
Yeah.
But then still, if I'm out and about and a kid wants to call me, I need to have a phone work.
You do.
I do. And so I have to pay $85 so that I can have a phone when a kid needs to call me. So anyway, stupid.
So have you been following the stupidity of the evergreen boat stuck in Suez Canal?
Yes.
So did you happen to look at the tidal tables for when they tried to take this boat of the absolute maximum size possible through the Suez? I can't say it. Through the canal.
Now you've screwed me up. Suez Canal. Right,
because I went to default to the Russian space capsule.
Yeah, exactly. The Soyuz Canal. But either is perfectly fine, I think. Yeah, the Suez Canal. So they took it during low tide.
So they didn't so much take it during low tide. They took it during high tide at quarter moon, which meant there really wasn't much of a high tide. And had they just waited a week, the water level would have been significantly higher. And there also wouldn't have been a
So an
massive
astronomer
dust
could
storm.
have helped. Yeah. Every ship should have an astronomer on board.
There's not that many of us, although
Yeah.
it would employ a whole bunch of out of
Yeah.
work astronomers.
What a mess.
It's so they're saying that if they don't get it refloated Monday, which is the next highest of high tides, it's probably going to be a few weeks.
I've got to assume they're trying to figure out how to unload it.
They're trying to figure out how to unload it. The Dutch company that is responsible for like when the Costa Concordia fell over on its side in the Mediterranean, they're the company that took it apart and scooped it up. They also have like giant things that they can pick up cruise ships and put them into dry dock.
Yeah.
So that salvage company is on the way to help. But I was talking with Allie, who used to work in shipping and is so grateful she no longer does and is our producer. So this is not her nightmare right now.
Right.
She gets to watch and enjoy with popcorn. But she was saying that there's just not enough floating cranes to be able to get in there and handle. It's the size of the Empire State's building.
Yeah. I mean, you see a million armchair shipping, logistics experts on Twitter going like, here's a helicopter that can lift it's the same thing as like.
Do you know how many trips it would take for that helicopter?
Who knows, right? There's all these armchair, it's like the armchair disease spread experts who are in the early phases of it. So. Yeah. Yeah, it's ridiculous.
I just love the fact that there was my first thought was look at the tide table and I was like, yep, you screwed up. Admittedly same armchairness, but
yes, but in theory you should be able to go down that canal all year long. Like they should be. I'm assuming they are.
This is the absolute maximum that you're allowed. So the issue is, it's just like sometimes cruise ships can only fit under bridges at low tide.
Right.
So the margin of error was 0.
Yeah.
And the margin of error that they have goes up the higher the tide is up.
Yeah. But I know I'm assuming they dredge the canal constantly. Anyway, we are not armchair shipping logistics people. All I know is you can see it from space.
Yes.
That's where we move back into the regime of things that we understand. We got the word that the launch has been delayed till Monday.
Okay.
So
that is sad.
Yeah.
I hope that it wasn't the new engine.
They were probably listening to me and they're going, yeah, maybe we should figure out the leg problem. But mark my words, boom. Bad legs or just too hard of a landing.
So I'm really hoping no boom, slight tilt.
Okay.
I went the leaning tower of SN11.
But a leaning tower is potentially a catastrophic failure of the spacecraft. If it's leaning, then things are crumpling. Well,
hopefully it's just I want crooked and no boom. This is my vote. You ask me my opinion. I'm ready for crooked, no boom.
Okay. Yeah, not what I want. What I want is a nice, safe launch and landing and a chance to test this out 1,000 times and for it to usher in an era of fully reusable 2-stage rocketry that ushers in humankind's exploration of the solar system. That's
I think we'll get perfection with SN12. That's really? My thought. Yeah.
Okay. Yeah. What I'm expecting is crunch, boom. Or maybe just crunch, and then it'll never fly again.
Right. That is indeed what I am expecting.
Yeah. All right. Well, you know what? We've reached the end of our hour. And both of us are starving, so it's time to go eat. Pamela, 600 episodes. What an honor and a pleasure to continue to be doing this job with you all of these decades later.
Yes.
And here's to 600 more.
Your children will be as old as we were when we started.
Yeah. My daughter's going to be 20 this year.
Yeah.
I know. My son is going to be 18 this year.
Yeah.
Yeah. Yes. All right. What are you working on that people can check out?
So right now I'm working on a whole bunch of website stuff behind the scenes. I've actually been actively programming. Next week I'm hoping to be able to do ninja streams of software, and I'm also um I'm going to be working on, this is a great winter studio because there's no heat in my upstairs office, and this stays warmer than the upstairs office does. But there's no air conditioning down here.
Right.
And there's air conditioning in the upstairs office. So I'm going to be working on flipping my studio next week. So I'll have air conditioning when I need it.
That sounds good. All right. Well, thank you, everybody. Thank you to all of the moderators in the chat. Thank you to our engineer and editor and producers helping us out. Thanks for everyone watching both on YouTube and on Twitch if you're out there. And all of our patrons who support the work that we do. Yes. And we will see you all next week for episode 601.
We're off next week. We're off next week.
All right. The letdown in 2 weeks when we hit 601. Nobody celebrates 601. That's just back to the slog.
No, but we deserve 1 week off after 600.
True that. All right. All right. Thanks, everybody. We'll see you all in 2 weeks. Oh, where did I hide my window now? Okay, there it is.
Yeah, with Passover and Easter.